Good morning, this is your Stat Sensei, Mr. Spensei, and this is Death Packet for Classical Probability Unit 3A, and this will be problems 1 through 10. So, a consumer group is investigating the number of flights at a certain airline that are overbooked. They're conducting a simulation to estimate the probability of overbooked flights in the next 5 flights. The results of 1,000 trials are shown in the following histogram. All right, so here we have 0.007 for 0.049, etc. Based on the histogram, what's the probability that at least 4 of the next 5 flights at the airline will be overbooked? Well, 0 is not at least 4, 1's not at least 4, 2's not at least 4, 3's at least not at least 4. Well, 4 is at least 4, and so is 5. So this is the probability that we're interested in. So we're just going to take 0.332 and add it to 0.114. And if I get my calculator here, we'll do that real quickly. 0.332 plus 0.114, and we end up getting 0.446. So our answer choice in this case is C. Okay. All right, moving on to number 2. Consider rolling 2 number cubes or 2 dice, each of which has its faces numbered 1 through 6. The cubes will be rolled, and the sum of the numbers landing face up will be recorded. That the event E represent the event of rolling a sum of 5. How many outcomes are in the collection for event E? Well, I need to make my sample space. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and finally 6, 1, 6, 2, 6, 6, 3, 6, 4, 6, 5, and 6, 6. All right, now I know that 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So there are 36 possible outcomes. All right, but they want to know the sum of rolling a 5. Well, rolling a 5 are 1, 4, 2, 3, 3, 2, and 4, 1. It's those 4. So 1, 2, 3, 4. And how many outcomes are there in this selection? Well, there are 4, because that's my 4 right there. So Amy has 12 brown golf tees, 8 white golf tees, 10 red golf tees, 6 blue golf tees, and 12 green golf tees in her golf bag. So there they are. There's my list of 12, 8, 10, 6, and 12. That's a total of 48. If she selects one of the tees from the bag at random, what's the probability that the tee she selects is not brown or blue? Well, in this case, they told us blue was 6 and brown was 12. So that's 18. So really, 18 out of 48 means if I add these numbers, those numbers will sum up to 30. 8 plus 10 is 18, plus 12 is 30. So we have 30 out of 48 because we wanted to exclude these. We don't want that to be our outcome. So if I take 30 and I divide it by 48, and then there's a button on the calculator that I want you to see, and that's the math, enter, enter. You hit math, and then you hit the enter button twice. You'll get the fraction, and so 5/8 ends up being our answer. The other way to have looked at this problem is go, well, if I take the brown and blue, now we have 18 out of 48, and I could have done 1 minus 18 out of 48, and it still would have worked. 1 minus 18 divided by 48, and I go, once again, math, enter, enter. And you go, how did I know to use the 1 minus? The word not. Not tells me I'm looking for the complement, which means a 1 minus situation. Okay? All right, moving on to number 4. Each person in a group of 20 people at a hotel orders one meal chosen from oatmeal, eggs, or pancakes. So really, we could have oatmeal, eggs, or pancakes. And we could have coffee or tea. So we could have oatmeal and coffee, eggs and coffee, pancakes and coffee. Or we can have oatmeal and tea, eggs and tea, pancakes and tea. So those are the possible combinations. And the first one, oatmeal coffee, oatmeal tea, eggs coffee, eggs tea, pancakes coffee, pancakes tea. So number 4, the answer choice is going to be A, because that's all my possible combinations. All right. Number 5 is based on simulations. In a certain population of birds, about 40% of the birds have a wingspan greater than 10. Biologists study the birds will create a simulation with 40 numbers to estimate the create a simulation with random numbers to estimate the probability of finding one bird in a sample of 6 birds with a wingspan greater than 10 inches. Which of the following assignments of the 0 through 9 will model the population? So we're trying to model the population, not the sample, and we know 40%. Well, if I look at this, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They told me that's the possible numbers, and so there's 10 of them, and I need 40%. Well, 40% of 10 is going to be 4. All right, so 40% of 10 is 4, and if you're not sure how to do that, just take 40 over 100, because that's 40%, because percents always go over 100 every single time. You can do this all the time, every time. And our total number was 10. And when we solve by cross products, 40 times 10 over 100, we end up getting 4. So I need 4 numbers. So let the even digits represent the birds with a wingspan greater than 10. Well, my list of even digits are 0, 2, 4, 6, and 8. That's 5, and I only needed 4, so that one won't work. Let the digits 0 to 1 represent the birds with wingspan greater than 10. Well, 0 and 1, that's only 2, and I need 4, so that won't work. Let 0, 2 represent the wingspan. Well, 0, 1, and 2, that's 3 different sizes, so that won't work. Then I go to 0, 3, and I go, well, 0, 1, 2, 3, that's 4. So this is looking pretty good right now. And then I'll check the last one, 0 to 4. Well, 0, 1, 2, 3, 4, that's 5 different sizes. So that's the wrong size. So our best choice is D. Number 6, at Mike's favorite coffee shop, the coffee of the day is either a dark roast, a medium roast, or a light roast. From past experience, Mike knows that the probability of the coffee being a light roast is 0.15, and the probability of being a dark roast is 0.25. So what's the probability of the coffee of the day not being a light roast or a dark roast? Well, we know this is 0.15, and we know the dark roast is 0.25. So the probability that it is a light roast or dark roast is 0.40. But we're looking for the not, and not is a complement, which means we're going to go 1 minus 0.40, and our answer choice should be 0.60. All right. Okay, moving on to number 7. Number 7, a business journal reports that the probability that internet users in the United States will use a mobile app is 0.60. So that means on average, in the long run, we'd expect 60% to do it. If we did repeated sampling, we're going to capture it 60% of the time. So the journal claims that this indicates that out of 5 randomly internet users, 3 will use the mobile payment. No, we expect if we did this over and over again. We can't say for a specific time. It's just like flipping a coin. I'm not guaranteed to get 1 heads if I flip it twice. I expect it to, but I'm not guaranteed to. So that means in the long run, I would expect it to. So here, the answer is going to be a no. They did not interpret it correctly because it's going to be in the long run, we'd expect it to have it happen. No, because 60% represents a probability in the long run or in repeated trials or for many samples. All right. So in the long run, for many trials and repeated samples, that's what we expect to happen. It's not what will necessarily happen on any one trial. This is true. 3 out of 5 is 60%, but it's not guaranteed to happen. It's what we expect to happen, but it may not happen. Okay. All right. Moving on to number 8. A financial analyst reports that for people who work in the finance industry, that's not going to be important in this question. The probability the randomly selected person will have a tattoo is 0.20, so 20%. Which of the following is the best interpretation of the probability of 0.20? Once again, we're talking about the long run. All right. For all workers in the United States, 20% will work in finance. No. For all finance workers, 20% will have a tattoo. So that's the wrong sample group. For all finance workers, 20% will have a tattoo. That looks pretty good to me. For all people with tattoos, 20% will work in finance. No, because 20% of those in finance will work. For a specific group of finance workers, 1 will have a tattoo. So 1 out of 5 is 20%. But we can't say it's for a specific group. It's for the total population, which is what this is for all finance workers. That's the total population. We can say it about the total, or we can say that's what we expect, but we can't say for an individual group or specific group. So that's not possible. And once again, we can't say for a specific group. So our best choice here is B because it's in the long run and we're saying for the entire population, and it will be true for the entire population, just not for a specific sample. Number 9, a certain spinner is divided into 6 sectors of equal size, and the spinner is equally likely to land in any sector. 4 of the 6 sectors are shaded, and the remaining sectors are not shading. So 4 out of 6. And by the way, you can probably reduce that in your head, but once again, I just want to remind you on the calculator, 4 divided by 6, math, enter, and I know that reduces to 2/3. All right. What is the best interpretation of the probability? Once again, in the long run, this is what I'm going to expect. So for many spins, the long run relative frequency with the spinner will land in a shaded sector is 1/3. This is really good explanation, except it needed to be 2/3, not 1/3. For many spins, the long run relative frequency, again, that sounds really good, but we're not looking for 1/3 or 1/2. We're looking for 2/3. For many spins, the long run relative frequency with the spinner will land in a shaded sector is 2/3. In other words, we did it over and again. We expect it to be 2/3, like this. For 6 spins, the spinner will land in the shaded sector 4 times. Well, you're going, well, that's 4 out of 6, but we don't like this because it's for a specific group. We're looking for a long run or in repeated sampling or for the entire population, not for a specific group. We can't say it for a specific group. And again, we're talking about a specific group, so it can't be that one. Our answer choice is C. Number 10, a fair die with his faces numbered 1 to 6 will be rolled. Which of the following is the best interpretation of the probability that the number landing face up will be less than 3? Well, if I'm rolling the dice, I can get a 1, 2, 3, 4, 5, or 6. Well, they want less than 3. And once again, that's my sample space. It really helps to make one, even though it's just a list of numbers. These are the 2 that I'm interested in. So 2 out of 6, which reduces to 1/3. So we're looking for in the long run, or if we do it repeatedly, or what we expect for the population. So for many rolls of the dice, the long run relative frequency of a number less than 3 landing face up is 1/3. I like this. Probably my answer. For many rolls of the dice, the long run relative frequency of a number less than 3 is 1/2. Wrong. The long run relative frequency less than 3 is 2/3. No. For 3 rolls of the dice, a number less than 3 will happen one time. Well, that is 1/3, but that's for a specific number, and we can't say it for a specific number. It will take 3 rolls of the dice before number 3 lands face up. It could happen on the first time. It could happen on the third time. It might not happen in 3 rolls. So our best chance is A. In the long run, we'd expect to see it happen 1/3. If we did it over and over again, we expect to happen at 1/3 of the time. All right, this will stop this video and hope to see you on the next one when we will do problems 11 through 20. Thank you.